Good morning, everyone. I learn only one Hindu language, Hindu word, Namaste. I'm very happy to speak here because India is my best company I want to visit. So I'm very happy now. And I'm very surprising. I wonder that so many people gather here. So I'm very happy. So let me take a photo of you. Thank you. I don't do, so this is not a Friday, so I don't do a Friday hug. So today I want to talk about this title, Speed Up Ruby Interpreter. My job, my interesting is speed up the software, especially Ruby Interpreter. So today I want to talk about how to speed up Ruby Interpreter in 10 years. At first, I want to introduce Ruby recent stable version of Ruby 2.1 and Ruby 2.2 as the next version of Ruby 2.2. And I want to show you how to speed up the Ruby interpreter by introducing my contribution to Ruby interpreter. Let me introduce myself. I'm from Japan. I'm a Japanese, and I'm from Japan. My name is Koichi Sasada. So my login name is KO1. So the name of KO, my given name includes this word, ichi. Ichi means one. So in Japan, the first person for my parents has it represents my first son of for my parents. So this means I'm a first person for my parents. So it is easy to understand, easy naming rule. And I married last year. I married, and in last April we make a wedding party. So, but the sad news is my wife can't visit here. This year I visit several foreign countries, and I'm very happy. Many people celebrate about this. Thank you very much. And I'm a programmer. As people introduce me, I'm a member of CRuby committer. So especially for the developing the virtual machine. Virtual machine is low-level infrastructure for Ruby interpreter. And recently, I working about improving the garbage collection performance and working as a Heroku matching. So I'm an employee of Heroku, and I contribute all of my time to develop Ruby interpreter to improve quality. I'm also a director of Ruby Association. So maybe you don't know about the Ruby Association, so I want to introduce Ruby Association. Ruby Association was founded to the future further development of the programming language Ruby. So the purpose of Ruby Association to encourage Ruby development. Ruby development has two meanings: developing Ruby interpreter and developing program with Ruby. So especially for the business. So we do many activities. Chairman is Matt, the original designer of Ruby, and this association located in Japan, and many activities. So maybe you don't know, but there is a certification program. You can get English tested, and if you pass the test, you can get a certification as you are good Ruby programmer. So visit this. Please Google about this one if you have any interest. Unfortunately, this test for certification is based on Ruby 1.8. So it is very old, ancient Ruby version. So now we are working on version up this testing. And Ruby Prize. Ruby Prize is for the award for new contributor of Ruby. Last year, Chikanaga-san get an award. If you got award, then the 100 1 mega yen, maybe 1 mega, 0.5 rupees about you can get. So this award is not limited to Japanese. So if you have any interest, please visit this site. And Ruby World Conference located in Japan. So not Ruby and World, but Ruby World. So it encourages the Ruby communities. So this event is also made by Ruby Association. And let me continue the advertisement. Maybe you know Heroku. Please raise your hand if you know the Heroku. Oh, very nice. Thank you very much. Thank you very much. Maybe you know better than me. I'm a member of Heroku, but I use only a few times of the Heroku service. So maybe you are experts. So please use one more. As you know, Heroku is a PaaS service, platform as a service. You can make you need to make only a program, and you can if you push the software to the Heroku, we help people maintain your application. We help you the deploy of your application in any language, not specified, not only in Ruby, but Java, Node, Python, PHP, and other languages. Heroku is Heroku is a popular service, I think, but Heroku is also contribute many open source softwares. Our employees include many open source developers. Especially, we have many open source software developer in Ruby. And also, Heroku employs 3 full-time Ruby interpreter core team, Mats, Nobu, and me. So the boss is Matsumoto-san, so we say Matsu. Matsu live in, all of Matsu, 3 people live in Japan. I live in Tokyo, and Nobu live in Tochigi, a bit far. And Matsumoto-san, maybe you know, Matsumoto-san is living in Shimane, a bit, it's so far. So we communicate with Skype and remote, others as remotely. Maybe you know Matsumoto-san. Matsumoto-san is original designer of Ruby, and also he is known as title collector. So he has many titles. So he is very popular person. So companies, association, and some organization call him. So please become some special job. So he has many titles. And also, Nobu is a great patch creator. Patch is a modification of Ruby interpreter. So this pie chart shows how many patches are provided by, and Nobu provides over quarter of patches. So in other words, Ruby interpreter is made, over quarter of Ruby interpreter is made by Nobu. He's very great patch creator. And also I'm known as an ETD developer. So this is, y-axis is commit number, how many commits I do, and this is a time chart. And this date, around this date, this is RubyConf, and this is Ruby, so release of Ruby 2.0, and Ruby Kaigi, you will call RubyConf. So I boost my development before event. So this means event-driven development. So I'm very happy to come here to boost my development. Thank you very much. And the mission of math team is improve the quality of Ruby, next version of CRuby interpreter. Maybe most of people using Ruby CRuby, so, and many people in worldwide. So our mission is to help such people, such CRuby users. As math team, Matsumoto-san decides everything, decides the specification, and no fix huge number of bugs. And my mission is to improve, to speed up the Ruby interpreter. And next version of our target, the next version of Ruby is Ruby 2.2. So for me, for math team, for me, Ruby 2.1 is old version. My current version is Ruby 2.2, not release, development version. So I want to ask you that how many people using Ruby 1.8? Nobody. Oh, great. Nobody. Ruby 1.9. Okay, thank you very much. It's an old version. Ruby 2.0, some people, thank you very much. It's old stable version. So how many people using Ruby 2.1? Oh, so many people. Thank you very much. Thank you very much. So many people. So a bit old stable version. Maybe I'm only one person using Ruby 2.2. So I want to introduce what's the difference from from Ruby 2.0 and Ruby 2.1. So Ruby 2.1 was released last year Christmas, and already we released Ruby 2.1.2 in last May. It includes some critical bugs, so please upgrade if you use old version. Maybe the biggest changes of Ruby 2.1 is the versioning policy. We drop patch level using from Ruby 1.9 to 2.1. Sorry, 2.0. Major version means big language feature, and minor version means inner language changes, and teeny version fixing represents fixing the bugs. So it means the same as the patch level of Ruby 2.0. So we bumped the version, major version at the 20th anniversary last year. So Ruby 2.0 is 20th anniversary version of Ruby. So it is possible to upgrade the Ruby 2 to Ruby 3 at the 30 years, but I'm not sure when the Ruby 3 is coming. Ruby 2.1 introduced new syntaxes. For example, Ruby keyword required keyword parameters. Ruby 2.0 introduced keyword argument. You can write this version a colon as a method parameter, a colon something, a colon 1 and something similar. And from Ruby 2.1, we can write b colon and empty. So it means that b is required. So without calling the b, specifying the b, you can't call. So it will be an error. So keyword argument is expand by required keyword arguments. And we introduce rational literals. So if you write 1/2R, it represents the rational to 1 and 2. So it is a small, short version of this syntax sugar. So to make this rational number, so we need to write a rational explicitly. So, but we can, we only need to write this one. And also, we introduce a complex number literals. So this is similar to rational number. Maybe in Ruby language, most of people doesn't need a rational, complex number. But if you need a complex number, it is easy to write the Ruby 2.0. And also, def syntax, definition of method, returns the name of symbol of this method name. So with this technique, you can use, you can write public method, static method, void method, and public void main def blah blah blah, if you like Java. Also, Ruby 2.1 introduced runtime new features. There is useful features, so please check it. And also, Ruby 2.1 improves the quality, improves the performance using string literal.freeze, sophisticated inline method cache, and introduce generational garbage collection. So generational garbage collection I do and I achieved, and today I talk about this one later. So, but the simple conclusion is generational garbage collector, it improves the performance of garbage collector dramatically. So the Ruby's garbage collector using the mark and sweep algorithm, and marking phase is very fast, 15 times faster. So it is achievement of Ruby 2.1, big achievement of Ruby 2.1. Next, Ruby 2.2 is planned to release next Christmas. So this year, maybe we can release Ruby 2.2. So we are here, and Decan RubyConf is here today. Next month, I go to Brazil, Ruby Kaigi, Ruby conference. There is a big event, so it is important for me as the event-driven developer. And Ruby 2.2 will release at the next Christmas, and we will make some schedules. So we will make a meeting, developer meeting, at the next week. So next week we discuss about the new feature of Ruby 2.2. So if you have any proposal, if you have any complaint, so if you have any worry about the Ruby syntax or some other features, so please tell me before Ruby this meeting, so we can discuss about it. We will make another developer meeting and fix the big feature changes at this preview one, September. And preview 2 is will be at November. And last, in December, we will release candidate version and release Ruby 2.0 final version. Just now, we don't have any big feature changes. No new syntax, no new methods. There is several small changes, but not so big one. But as internal feature aspect, there is several changes. CAPA changes and garbage collector changes and virtual machine changes. So I believe we can improve the performance more. So simple GC is maybe biggest change. So if you do this program, so 1 million times, iterate 1 million times, and make a string and change to symbols. So this means that making the 1 million symbols, and this line symbol.o symbol.size returns the size of symbols the interpreter has. On Ruby 2.1, it returns 1 over 1 million. So symbol cannot be corrected. But Ruby 2.2 development version, it's only a few symbols. So this shows that we can correct the symbols if we don't. So if the symbol is not needed. So symbol GC collects the dynamically created symbols. Okay. Break time. So today's main topic, speed up Ruby interpreter. I wanted to show you how to speed up what I did to improve the performance of Ruby interpreter. Ruby, basically software consists of many components. So as Ruby interpreter, there are some components. Ruby interpreter loads the Ruby script, your application, and pass it and compile it and make a Ruby bytecode. So Ruby bytecode is evaluated by evaluator. So especially some people say this is a virtual machine. And this evaluator is, so we need to manage the objects. It includes the garbage collector, and we need to maintain the threading. And also many embedded classes are needed. So for example, you use string class, array class. They are embedded classes. And also, outside of interpreter, you use the boundary library and gem libraries. So Rails is also gem. So Ruby interpreter consists of the many components, and this is they are very low level components. So to speed up, to improve the performance, we do, and I do hacking with about these components. So today I want to show you how to improve the performance for each component. So virtual machine I developed from 2004. So this is 10 years anniversary of my development of virtual machine. So I want to show you my 10 years achievements to speed up Ruby interpreter. At first, I need to show you the evaluator. Evaluator is, at first we start development Ruby interpreter virtual machine at 10 years ago. This is a simple stack machine and execute each bytecode instruction one by one. It's a very simple architecture, but it can be improved the performance. So there are many knowledge, optimization knowledge to improve the performance. So for example, Ruby interpreter parse Ruby program. For example, A equal B plus C. So Ruby need to understand what it means. So pass to the abstract syntax tree like that. And Ruby 1.8, before Ruby 1.8, they traverse these abstract syntax tree to execute it. But on YALP, we compile to the bytecode, sequential bytecode. So this is a tree data, and this is a sequential bytecode. So it is easy, it is fast to compare with traversing the tree data. And execute on the simple stack machine. So this is a compiled bytecode, and this is a virtual machine stack. So this means that the stack machine means using the only as one stack. So this instruction push the local variable b to push to virtual machine stack, and this instruction also push the stack C, and this instruction adds the number of this on stack, and at last we set the result of this one to the local variable A. So this is a simple mechanism of instruction YARP virtual machine. There are many optimization techniques, many optimization techniques. So I applied everything like this. So many techniques. So I don't have enough time to introduce everything. But one big policy is analyze the behavior and find out the bottleneck and optimize the frequent case. So for example, exception handling mechanism, we need to take a cost to handling the exception. But exception becomes exceptional. So it means there is an exception handling code. So there is a begin, blah, 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 ensure, blah, blah, blah. And exceptional case, occurring exception is exceptional. So it is not frequent. So we optimize for non-exceptional no-exceptional control flow. So this is a simple policy about to optimize. So we apply the many optimization. So this shows how speed up compare with Ruby 1.8. Apply some optimization and apply everything, then we can get very fast for small benchmarks. So we do many optimization on simple stack machine, and we can get high performance compare with Ruby 1.8. So thread management is important feature, important component. So threading, so to use the threads, before Ruby 1.8, we use user level threads, but we change native threads to use Ruby threads, to maintain Ruby threads. And maybe you know the parallel execution is not allowed by Giant Virtual Machine Lock GVL. You cannot, yes, but you can free GVL if you write thread safe code in C level, and we can run it in parallel. Ruby 1.8 and before, only one native thread are used to change the threads. But this shows the layered view from hardware and operating system and Ruby interpreter. Operating system provides a native thread. Only one native thread are used. But I changed to use two operating system native threads with Giant Virtual Machine Lock. So if only one thread can run in this interpreter. So layered view, there are several native threads, and there is a corresponding native thread for Ruby threads. So I know you don't like Giant Virtual Machine Lock, but I think to protect Ruby users, it is needed. So this means that the thread programming is very difficult, nightmare debugging, because of the sharing everything. So I think we need to introduce some protection, some isolation feature to introduce a parallel threading or parallel something. So this is a critical issue I need to challenge here. And the garbage collector. Ooh. If you write object.new, then object is created. One object is created. And also, this foo string literal creates one object. So everything is object, and object creation is everywhere. So we don't need to write the allocation object manually. So this is because there is a garbage collector. So the garbage collector collects automatically, collect the object automatically. You don't need to care about the object allocation. Garbage collector recycles the unused objects automatically. So Ruby interpreter uses mark and sweep algorithm. So there is a root object and marking all of root objects. So we can understand the traversable objects use objects. So we traverse all objects and mark them, and there is no marked objects. So sweep them. and freeze. This is a simple algorithm of Ruby interpreter using. And also we boost the performance of mark and sweep objects. So generational garbage collector based on the weak generational hypothesis. So this means that most objects die young. Most objects die young. So we can concentrate the reclaiming the effort only on the young object. So in fact, so I measure the object lifetime, and most of 95% of objects are die dead in by the first garbage collector. So most of objects cannot survive one more garbage collector. So the idea is separate the young space and old space. So so this demonstrates the generational garbage collector. So traverse one. So if we mark the one object, mark it and check it old. So these objects marked old objects. And the next garbage collection, the minor garbage collection, it traverses only new one. So we can understand this is the old one, and the old one can hold old objects. So we can skip the marking of these old objects. If we don't have enough memories, then we mark and sweep the all objects. So this is a trick of generational garbage collector. And as I show you the performance of garbage collector, we can speed up the 15 times faster than the normal marking time. And this is a total application time. We can improve the 10% of application time. We can eliminate the 10% of time. So this means that if you upgrade Ruby 2.0 to Ruby 2.1, this is possible to improve the 10% performance. So I show, so there is a short time, so I show the brief description, but I say the some techniques to improve the performance. So how to make it is, how to speed up is do everything. If we don't touch some components, we can't speed up enough. So we do this one, and this one in 10 years, and we can get the current performance. So we optimized several components, and we are doing to improve the performance, and we will do to improve the performance, to improve the quality. And this is what, so only continuous effort improves the software quality, I think. So this is same as for your applications. If you continue the software development 10 years, the software will be a very nice software. The quality of software will be nice. I believe that. And there is no other solution to improve the performance, to improve the quality of software, I think. Of course, there is many future work. So I need to talk to that. So today, I show you the Ruby 2.1 and Ruby 2.2, and how to improve the performance for each component. And one answer, so I show you the one answer, is continuous software development is how to speed up, how to improve the quality. So thank you very much. Do we have a question time?
So we have
For example, why GVL has or some other typical questions. So please ask me after this. Oh. Yeah.
So, hi, thanks for the talk. So I was just going to ask about transactional memory. So Python has started the PyPy over STM thing. Are we thinking about anything like that in Ruby?
Transaction memory is very nice abstraction to use the parallel execution, and I think it can be. But the problem is syntax or programming model. Clojure is a Lisp, one of Lisp interpreter using the transaction memory, but the side effect is closed by transaction memory. All of side effects is closed by transaction memory, and this is why Clojure is nice. So if you order to use transaction memory, if you want to assign the variable, then maybe many Ruby programmer cannot write such a code. Many programmer want to make many side effects easily. So the programming model is the issue. I think software transaction memory or hardware transaction memory is one way to go to use parallel execution. But just now, we don't have any good knowledge, good syntax idea, good programming model idea to use it. So idea is welcome. Thank you.
Any other questions? If not, thanks, Koichi.
Thank you.